Hello everybody, this is a teacher Growth and this is your channel. Please subscribe before. If you subscribe, you will get notification when you upload any video for education. Thank you. So today, let's deal with this module of planning or maths instructions. We talk about how to plan maths. So let's start on setting mathematical objectives. How you can set your objectives when you are teaching mathematics. Instructional objectives must be in terms of behavior, learning, precise, specific, measurable, achievement, relevant, and time-bound smart. Those objectives, if we combine them and we make this abbreviation of SMART, which means specific, measurable, achievable, relevant, and time-bound. They should reflect different levels of functioning knowledge in three cognitive students levels: technical, which is computational; the level of mobilizable, which is application; and the level of available, which is comprehension. We have common format of objectives: subject, verb, and object. This is a common format of objectives, or format of how we make objectives. A student will students will or should or might or demonstrate means that here subject is a student or learner, and the verb is it can be will, should, might, demonstrate, etc. And object the verbs precise the student's activity or the cognitive process category, adapted from the original Bloom's taxonomy of educational objectives. There are 6 cognitive process categories. We have 6 cognitive process categories. Cognitive domain of educational objectives. Let's continue with raise cognitive domain of educational objectives. And above, we have seen that we have 6 cognitive process categories. We have Bloom's reversed. Is there a difference between content and knowledge? Firstly, let's define what is a content. Content is a subject matter specific. If you focus on a content, then you don't need as many taxonomies as there are subject matters. Example, one for science, one for history, etc. Bloom's taxonomy summarizes the level of knowledge from any content. Content exists outside the student. Teaching activity is a mean to get the content inside the student. When a content gets inside the student, it becomes knowledge. Together, when a content gets inside the student, means that when the students already acquire the content, it becomes knowledge if they get it. If a teacher transfers the content into students, at that level, the content, it becomes knowledge. The transformation of content to knowledge takes place through the cognitive processes used by the student. Content versus knowledge. Content will be transformed into knowledge through cognitive processes. Cognitive processes or action verbs. We have remember, recognizing, recalling. We have understand, interpreting, exemplifying, classifying, summarizing, inferring, comparing, and explaining. Cognitive process, continue it. Let's continue. Apply, executing, implementing. All these verbs are action verbs. Analyze, differentiating, organizing, attributing, evaluate, checking, critiquing, create, generating, planning, producing. All those above verbs are action verbs, which is used in the cognitive process when you are transforming content into knowledge. And here we have 4 types of knowledge. Knowledge, it's classified into 4 types. You have a conceptual knowledge, and you have a procedural knowledge, and the metacognitive knowledge. Conceptual knowledge is the interrelationships among the basic elements within a larger structure that enable them to function together. Conceptual knowledge is the interrelationships among the basic elements within a larger structure that enable them to function together. Procedural knowledge, how to do something, methods of inquiry, and the criteria for using skills, algorithms, techniques, and methods. Do you understand what is it? Procedural knowledge. It is how to do something, methods of inquiry, and the criteria for using skills, algorithms, techniques, and the methods. Means that is a procedural knowledge. It's concerned with how to do something, which are methods, criteria of using skills, techniques. Yes, it's how. And the third one is metacognitive knowledge. the metacognitive knowledge. Metacognitive knowledge is the knowledge of cognition in general, as well as awareness and knowledge of one's own cognition. Knowledge of cognition in general, as well as awareness and knowledge of one's own cognition. This is what we call metacognitive knowledge. And here we have the taxonomy table of knowledge. This table is for taxonomy. And I have 1, 2, 3, 4, 5, 6, 7, 8. We have 7 column and 1, 2, 3, 4, 5, 6 and 6 laws. And the second column we have number 1, which is in member. This table, in these columns, there is the action verbs, what we have seen above, where on the other column we have A, B, C, D. However, there is above 4 types of knowledge. Okay. First, it's remembering, reorganizing, and recording. Understand, interpreting, exemplifying, classifying, summarizing, interpreting, comparing, and explaining. Number 3 is and apply, executing, implementing. And number 4, analyze, differentiating, organizing, and attributing. Number 5, evaluate, checking, critiquing. And number 6, we have create, generating, planning, and producing. Where on the column we have number A, which is factual knowledge, conceptual knowledge, procedural knowledge, and the metacognitive knowledge. A and the 1, they have A1, A and 2, A2, A3, A4, A5, and A6. Means that all these types of knowledge, they match together with these action verbs. Okay, let's continue. We have what we call affective domain of knowledge. What is affective domain of knowledge? It refers to dealing with things emotionally, such as feeling, values, appreciation, and attitudes. It considers receiving phenomena or awareness, responding to phenomena or active participation, valuing, organization, internalizing values, or what we call characterization. And the next is psychomotor domain of knowledge. It involves physical movement, coordination, and use of the motor skills areas. The development of these skills require practice, and is measured in terms of speed, precision, distance, procedures, or techniques in execution. So it includes perception, set or readiness, guided response, mechanism, complex overt response, complex and beta movement, adaptation, modification to fit special requirements, and orientation creativity. Number two is assessment in mathematics. Assessment in mathematics or in maths is used to monitor curriculum implementation. Yeah, as we have seen in the previous model of curriculum development, we have seen that when you want to check if your curriculum when you want to check if objectives set in your curriculum have been achieved, you have to make this curriculum implementation. You have to implement all those content or those things which is contained in your curriculum. So in order to know if your objectives contain set in your curriculum, you have to use assessment. You have to assess if your curriculum implementation it is gathering information on what students know, what they can do, and what their disposition are. It is integral part of instruction. Effective assessment of school maths should reflect the maths that students should know and be able to enhance math learning, promote equity, be an open process, promote valid reference, and be coherent process. To increase the reliability, the following should be eliminated from test items. Questions that discriminate or distinguish between children whose abilities are different. Questions that are frequently misunderstood by children. Questions that give advantage to some children on the basis of factors other than those being tested. The following guidelines should be used when constructing a test. Avoid wording that cause confusion or ambiguity. Avoid trick questions. Generate independent solution questions. Set questions that cover as much of the learning as possible. Set questions that have convergent solution. Require students to attempt all questions. Arrange questions according to the level of difficulty. Before setting a test, list all topics and concepts to be tested. A table of specification is useful in determining which skills have been tested. And the following is the steps in preparing the table of specification. Steps in preparing the table. Steps in preparing the table of specification. We have list down the topics covered for inclusion in the test. Determine the objectives to be assessed by the test. Specify the number of days, hours spent for teaching particular topic. Determine percentage allocation of the test items for each of the topic covered. The formula applied is as follows. Percent for topic equal to topic number of days or hours spent over the total number of hours days spent teaching topics. Example: Mrs. Glacier utilized 10 hours for teaching the unit on the Spanish Philippines. She spent 2 hours in teaching the topic 80 Philippines and their society. What percentage of test items should be allocated for the topics? Percentage will be equal to 2 over 10, which is equal to 0.2 or 20%. Determine the number of items for each topic. This can be done by multiplying the percentage allocation for each topic. This can be done by multiplying the percentage allocation for each topic by the total number of items to be constructed. Example: Also, Miss Gracia decided to prepare 30-item test on the unit for the Spanish Philippines. How many items should she write for 80 Philippines and their society? 20 items times 0.2 equal to 10. Distribute the numbers to the objectives. The number of items allocated for each objective depends on the degree of importance attached by the teacher to it. Objectives: topic, knowledge, comprehension, precaution, analysis, and the total. Introduction on 5 is as Instructional Model. We have engage, explore, explain, elaborate, and evaluate. How to instruct: learner-centered, inquiry-based, and effectively. Designed this model in mid-1980s. This model is widely used and tested in education. Okay, let's take a pause, small pause, and continue with engage and excite. Students, don't go far from us. Okay, let's take pause of few minutes and back with continue with our model. Okay, thank you. Let's back soon.
Okay, thank you, students. Thank you. We are back now. Let's continue with our model. We finished to drink water and take a pause. Okay, let's continue as I told you before. We are going to start on engage or excite. How much paint does a painter need to decorate your bedroom walls or ceiling? Look at this jar. Here you have jar. Look on this. Look how they painted well, they prepared well, they sang or they looking well. Can you rephrase this problem? Can you turn this into mathematical question? How can you know how much paint you need? Take a close look at the instructions on the paint. How much paint is in this jar? How much surface can you paint? We have to rephrase the problem. What is the total surface area of your bedroom that needed to be painted? Imagine your room. What sort or polyhedron does your room looks like? What is the difference between the surface area of a keyboard and the area that must be painted? So we can rephrase the question with the elimination of the surface, the floor, to the key question. Activities in this class or engage or excite. Here we have a table. We have teacher activities and learners activities. So in the lesson on the and in a teacher activities demonstrate puzzling or discrepant phenomena, defines challenging problem, tell us about a special historical event, shows puzzling a picture or video, activate prior knowledge of the learners, stimulate the learner to observe and to formulate interesting questions, helps learners to select good key questions. Learners activities, try to get first understanding of phenomena, ask questions why, how, formulate a key question. Outcome, engage the learners key questions. Result of this class is key question of the lesson effectiveness of the engage excite phase. Examples, what is surface area of keyboard? How to explore. Explore phase. Look at the model of keyboard representing our room. Draw 3D model on your paper. How many faces, edges, and vertices? Label each vertex with ABC. Point out length, height, and width. Draw labeled net of keyboard. Tip. Look at the 3D model in the keyboard and you have to unfold it in a way that it will become flat. How would you calculate the surface area of the net? This is a keyboard. Teachers and learners activities in explore phase. Yes, these are teacher activities and the learner activities. To explore, students build own understanding of key question. Often involves group work or demonstration as concrete as possible. The teacher collects insights on students' ideas, initiates here main ideas from explaining phase. One group gives explanation, other groups listen and help to improve Teacher helps by questioning if necessary and introduce scientific, mathematical, or technical explanations in direct, explicit, and formal manner. So we stop here our lessons, and the following let's may play this or notes, and you have to look on it to see all chapters which will be covered with us in these modules. Thank you so much, and continue this play of our notes. Thanks. Yes. Thank you guys. This is our presentation. Okay, you be study in this video. There are many actions, but no problem. All are education. Our purpose is to improve education. Okay, I'm teacher Claude. Thank you so much. What you're supposed to do on this channel is to subscribe if you don't do before, and to share our videos, to like our videos, to comment. And guys, we need your comments, please. We need your comments. So thank you so much. We'll come back with many lessons, many subjects, many knowledge. So let's we promote our education together. Thank you so much. Thank you.